So now we are going to close this cycle by adding the cooler. So here we are looking for our cooler. Okay, so the condenser that we are using here is just a cooler. Okay, we are going to open this one. The inlet, we know the inlet will be our stream number 4 and our outlet will be stream number 1. So that's how this one will be closed. Okay, so now it's a closed cycle. We need an energy stream over here, so this one will be our cooler Q dash Q. So now we are asked about the delta B. Before we have discussed where to find the delta B information, the design parameter. So usually if you are asked about information over here, just go to the design parameter. It's directly after the connection. So now I have the inlet and the outlet and the energy stream, and I'm given that I have a delta B of about 35. Because we have struggled before with the delta B, so we are going to keep it like simple. If it's 35 is not working, we can try another one. For the delta T here, we have the temperature dropped by 11 degrees Celsius. Okay, so now after adding this information, we will find out that our compressor is also solved, not only our cooler. So I just want to go and enter the cooler, and it's similar to the heater, but let's cover it. We have the connection, inlet and the outlet and energy stream, because we are removing heat from this cooler, so the heat will be removed. So this is an out, like this one, this is an out stream. For the parameter here, we have information about the delta B. We can define the cooler by the delta B and the duty or the temperature at the exit. So let's cover this section for the cooler. Okay, so for the cooler duty, it will be similar to the heater. The Q or the duty is equal to the flow, the mass flow, CB multiplied by delta T. So this is your duty, this is your mass flow rate in kilogram per hour, and this one in kilojoule per hour. This is the specific heat, so, and this one is the delta T. So if your cooler is lowering the temperature from 20 degrees Celsius to 5 degrees Celsius, we have now a delta T equal to outlet, which is 5, minus the inlet, which is 20. So the delta T should be negative, and it's now negative 15. That's why the delta T in our Aspen HYSYS simulation is or has a negative value. Okay, so we can define the cooler by having the information about the delta T or the Q or the duty. Okay, so back to our simulation over here, we have a delta T in negative, and we can define the simulation by having information about the delta T or the duty. Here we have information about the exit temperature. So this one was given to be 50 at the beginning. So now this cooler is solved by knowing the delta T. Okay, it's also important to arrange. So this one is difficult to understand that if it's a closed loop or not. So here we can go to the flow sheet, and you have a rotate and flip, and so you can flip horizontal and vertical. So usually I try like this one. When I flip it horizontal, it's well arranged. Okay, so this one, the compressor energy. So now I have stream number 1 entering the valve to chiller, 3 is entering the compressor, and 4 is entering the cooler. So this one needs to be flipped horizontal also. So after flipping it horizontally from this section, it is flipped, and the 4 is entering the cooler. So this one is for the energy stream. This one I'm going to give it a name, which is a condenser. I forgot to give it a name. Okay, so this C need to be capital, condenser, and that's it. Okay, so now we have already done all or enter all the information. Just don't forget to save your case. Okay, and what else I'm going to show you in this video is the workbook. So if I look here, I click here, so we are in the simulation and we have finished the simulation, and I want to display the data inside it. So if you click the worksheet here, you will have these different tabs. The first one is for the material stream. We have 4 material stream. Okay, so this one is named wrong. Okay, that's why it's really important. Like this one is stream number 4, and this one here, this one is a condenser. Okay, the design, this one is the condenser. Okay, so if we again go back to our worksheet, we will have 4 material streams, 1 2 3 4, and for the composition we can have it's only propane. Okay, so the propane is written here, and we have 100% propane. If we have different compositions, it will be displayed over here. For the energy stream, we have an energy stream for the chiller or the heater, an energy stream for our compressor, and also for the cooler, so you can display all the information that you have from him. These are the different unit operations that we have. This is the GT is just a valve, the chiller is just the heater, and so if you have like unit operations that you don't know what is the object type, you can view it from the worksheet over here, or you can open this one. Like if I open this one, it's named GT, but it's just a valve, so this is the object name at the beginning. Okay, back to our worksheet, we have the unit operation over here. Okay, this is the main flow sheet. If you have information related to a sub flow sheet, you can also check these two information. Okay, so till now we have covered the worksheet. For the unit operation, you have the chiller, the compressor, so you can display the information like this one. For the stream over here, we have 4 material streams. So I'm choosing each one, and 3 energy streams. Okay, for the stream analysis, we haven't done any stream analysis over here, but we have done this before, so you can you feel free to display any stream analysis that you want to add from here, or from the stream analysis, or from inside the stream itself. Okay, so now we have finished our case. So in our next video, we'll cover how to customize our HYSYS workbook. So this workbook over here.